Hi, my name's Joel Gordon. I'm with the Museum of Discovery, and you're watching STEAM. That's Science, Technology, Engineering, Arts, and Math. And today we're talking about space, because right now, as I'm recording this video, there's a huge asteroid that is hurtling towards Earth. Don't worry, it's not going to hit us, but it is going to come really close. It's called Asteroid 2012 DA14. Go look that up. It's really interesting. Now, here's the deal with DA14. It's going to come really close to the Earth. How close? Well, look at it this way. The moon is around 200,000 miles away. DA14 is going to come right into the area that our satellites are orbiting the Earth. That's low Earth orbit. It's about 17,000 miles away. 17,000 miles to 200,000 miles where the moon is. How big is DA14? Well, it's about the size of a football field, which seems pretty big. But imagine looking at a football field 17,000 miles away. That's not so big. Every once in a while, something does hit the Earth. In fact, we see them enter the atmosphere all the time. You may have seen what we call a shooting star moving across the night sky. That's not really a star, that's a meteor. And when they hit the Earth, they're called meteorites. This is a meteorite. In fact, this is a Sukhote-Alin meteorite, and it hit the Earth back in 1947. It was witnessed by thousands of people in the Sukhote-Alin mountains in Russia. The material that was left over was about 70 tons. That's a lot of meteorites. Now, this meteorite is made of iron and weighs about 50 pounds. So if that's okay with you, I'm going to put it down. And I'll pick this one up instead. This is a Gibeon meteorite, and it hit the Earth, well, in prehistoric times. So it's been here for a long time. Now, the really interesting thing about this is if you cut a meteorite open, metal inside. In fact, most meteorites are iron. The reason that most meteorites are iron is that that material doesn't melt when it enters the atmosphere and heats up. It makes it all the way to the Earth. Now, the Gibeon meteorites were found in Namibia, on the coast of Africa. And the really interesting thing about them, when you get up nice and close, you see a pattern. In fact, that pattern almost looks like, I don't know, a circuit board or a machine. Some people imagine that these were made somehow. But really what it is that all metals are crystalline based. Now on Earth, when metals heat up and then cool rapidly, you don't get a chance to see this sort of crystalline pattern form. But with the Gibeons, they traveled through space for thousands of years. They cooled at about 1 degree Celsius per 1,000 years in order to get this pattern. That's pretty rare and really interesting. Now, if you think you might like to be a meteor hunter, you don't need a lot of fancy equipment. All you need is one of these. Okay, it's not much. What it is a magnet, a really strong magnet on a string. So go out in your neighborhood and go test the rocks that you see laying around. If your rock does this, it's probably a meteorite because it's made of iron and it attracts the magnet. Just like that. So if you find a rock and your magnet sticks to that rock, then hold on to it, take it into your local university, go to the physics department and talk to an astronomer. You might just have a meteorite. So good luck hunting. I'm Joel Gordon with the Museum of Discovery. This has been STEAM, that's Science, Technology, Engineering, Arts, and Math. Thanks for joining us. Be sure to subscribe, and if you have a comment, leave it. Then we know what we want to talk about, because we want to talk about what you want to talk about. I'll see you later. Oops. That's strong. Magnets. Oh, quit.